In this video, we're going to take a deeper look at conditional statements. Conditional statements are if-then statements. So if something happens, then something else happens. And we use this arrow to indicate a conditional statement. So the first part that has to happen comes first, and then there's the arrow, and then there's the second part. The if part is called the condition or the hypothesis. So that's the A here in blue. If the condition happens, then the conclusion happens. So the conclusion is the second part, or the B here in red. A converse of a conditional statement is when we flip the condition and the conclusion. So we say if B, then A. And a converse is not necessarily a true statement. So like the other examples that we saw previously in the activity, we could write the converse and it could be true, or we could write it and it could be not true. It all depends on the context. And finally, a biconditional statement is true in both directions, and we use this double-sided arrow to indicate that a statement is biconditional. So if the statement itself is true and the converse is true, then it's a biconditional statement. So, question 1 has two sentences. If something has stripes, then it is a zebra. If something is a zebra, then it has stripes. Which of the two sentences is true, and how do you know? So if something is a zebra, then it has stripes. I know that this is true because if I have a zebra, I know that it's going to have stripes. So the second sentence is true. We know that a zebra, if we have a zebra, it is going to have stripes. Now, think about the first sentence. If something has stripes, then it is a zebra. Is it possible to come up with something that has stripes, but it's not a zebra? If we can come up with something like that, then it's not true. So this sentence would be not true. So the first sentence is not true because we can have something that has stripes and it is not a zebra. So for example, it could be a cat, it could be a shirt, doesn't even have to be an animal, but anything that has stripes, that is not a zebra. So if something has stripes, that doesn't mean that it's a zebra. If something is a zebra, it does have stripes, assuming there's no zebras that don't have stripes. So when we're thinking about if making something false, something is false if a conditional statement is false if the first part is true, but the second part is not true. So looking at question 2, decide whether the statement is true or false. If false, give a counterexample. So a counterexample is an example of something where it's not true and something that shows that it's not true. So our example up above, a cat would be a counterexample. If something has stripes, then it is a zebra. A cat is a counterexample to that because a cat can have stripes, but it's not a zebra. So question A, if I have 25 cents, then I have 2 dimes and a nickel. So can I have 25 cents and have it be something other than 2 dimes and a nickel? Well, yes, I could have 2 dimes and 5 pennies, I could have 5 nickels, I could just have 1 quarter. There's lots of other ways that I could have 25 cents that are not 2 dimes and a nickel. So this one is false. And any of those examples would be a counterexample. So I could have, we'll use 5 nickels. So again, something where the first part of the statement is true, the condition is true, but the conclusion is not true. Question B, if a number is divisible by 4, then that number is divisible by 2. So think about numbers that are divisible by 4, like 4, 8, 12, 16, going on up. all of those numbers are also divisible by 2. So it's not possible for me to have a number that is divisible by 4, but it's not divisible by 2, because anything that's divisible by 4, you can divide it by 2 and then divide it by 2, and that's the same as dividing by 4. So this one is true. It is not possible for a number to be divisible by 4 and not also be divisible by 2. So we know if we have a number that's divisible by 4, it's also going to be divisible by 2. And then question C, if a figure is a rectangle, then it has 4 sides. Is it possible to have something that's a rectangle that does not have 4 sides? No, all rectangles have 4 sides. That's part of the definition of a rectangle. So this is true. You cannot come up with a rectangle that does not have 4 sides. So if we have something and we know it's a rectangle, then we know that the conclusion is also true. It must have 4 sides. Question 3. Consider the statement. If your body temperature is 103 degrees, then you have a fever. Question A says to identify the condition and the conclusion of the sentence. So going back up to our definition box up here, remember the condition is the first part and the conclusion is the second part. The condition is the if and the conclusion is the then. So my condition is the your body temperature is 103 degrees part of the sentence. And the conclusion is the then part, which is you have a fever. Part B says to write the converse of this statement. So going back to our definition box, the converse means we write if B, then A. If conclusion, then condition. So we're switching the conclusion and the condition. So if you have a fever, that's the conclusion, it's going to become the condition, then, and then we put the condition, is going to become the conclusion. So if you have a fever, then your body temperature is 103 degrees. Is this true or false? If true, explain why. If false, give a counterexample. So if you have a fever, is your body temperature 103 degrees? Well, it might be, but it might not be. So the answer is no. You can have a fever with a temperature of 101 or 102 or 104. So it's possible that the first part is true and the second part is not true. So you could have a fever with a body temperature that's not 103 degrees. Still a high temperature, but not exactly 103. And lastly, question 4. If a soccer game in the knockout round ends in a draw or a tie at the end of 90 minutes, the game continues into overtime. Is this a biconditional statement? So let's look at our if and our then. Our if, a soccer game in the knockout round ends in a draw at the end of 90 minutes. So a soccer game has ended in a draw or a tie. And then our then, well, the word then isn't here, but it's sort of implied. Then the game continues into overtime. So if we flip these two around, if the game continues into overtime, then the game has ended in a draw or a tie at the end of 90 minutes. That is true. If a game goes into overtime, that means that it ended in a tie. It would not go into overtime if there wasn't a tie at the end of the regulation. The game would have just ended if one of the teams had been ahead. So this is a biconditional statement. Remember that a biconditional statement means that it's true in both directions. So the statement itself is true and the converse is true. So I know that the statement itself is true. If a game ends in a tie at the end of 90 minutes, the game continues into overtime. And also, if I flip it around, it's still true. If the game has continued into overtime, that means that it must have ended in a tie. So, since both the original statement and the converse are true, it is a biconditional statement.